Students, today we will learn Wheatstone bridge. Charles F. Wheatstone was a British physicist, and he proposed that if five resistances are arranged in this way, one is this, let this be P, and second resistance is this, let this be Q, third resistance be this, let this be X, and let fourth resistance be R, and fifth resistance is S. These resistances are joined are in this manner. Then, and if battery is joined, Wheatstone made it that if no current passes through X, then resistance of P divided by resistance Q is equal to resistance R divided by S. That means if no current passes through X, then resistance P divided by resistance Q is equal to resistance R divided by resistance S. And this will be the battery. Clear? And let A plus B current is coming through this battery. So this current is distributed here, A and B. And this current A current will reach here, B current will reach here. I can send some current to X from B also, and I can send some current to X through A also. It is I have that much liberty that I can choose any A or B and distribute the current. So I am distributing from A. So let A current reaches here, and some current C passes through X. And when some current passes through C, and this current will come here, and B and C will join together, and it will pass through S, B plus C. It is B plus C. And A current reaches here, and C current passes through here. That means the rest of the current will pass through R. So A minus C current will pass through R. Now I can use Kirchhoff's loop law. I can take a clockwise loop or anti-clockwise loop, whatever you wish. You can take. Let's take clockwise loop. Clear? And here again I am taking clockwise loop. No problem. You can take clockwise, anti-clockwise. You can take clockwise, clockwise. You can take anti-clockwise, anti-clockwise. No problem at all. It's upon you have the liberty to choose it. Loop. So using Kirchhoff's law. We know that sum of EMFs is equal to sum of current into resistance. So no EMF is here, so that is 0. No EMF is 0 here, so 0 in this loop. No battery is here. So EMF will be 0. And what we have learned here, direction, clockwise direction. This is the clockwise direction. So current and loop are in same direction, then IR is positive. That is our convention. So here current and resistance are in same direction, so it is going to be positive. So it is going to be A into P. And here it is C into X. And here current in this direction and loop is in this direction. So here it is minus B into Q is equal to 0. So sum of EMF. So there is no EMF, so sum of EMF is 0. And also condition is that the no current passes through X. So C should be 0. So if C is 0, the equation is becoming A into P. That is AP. That is A into P. This is we have to prove. This is to prove. And since no current is passing through X, so C is 0. This is the condition. So if C current is, we have considered that C current is passing through X, so C should be 0. So it is 0 minus B into Q is equal to 0. That means we get AP is equal to B into Q. This is being your first equation. Now let us solve the second loop. Again you see that here the loop and current in same direction. So R into A minus C, it should be positive. And here current is in this direction, current is in this direction, and loop is in this direction. So it is going to be negative. So it is minus S into B plus C. Clear? And for this resistance, current and a loop are in opposite direction. Loop is in going this direction and current is in this direction. So it is going to be minus Cx, minus C into x, and that is sum of the EMF. And since there is no batteries connected in this loop, so sum of the EMF should be 0. Now C is 0. The basic condition that if C is 0, so we will take C is equal to 0. So here was the equation, R into A minus C plus S into B plus C and minus C into x, minus C into x, clear, is equal to 0. So and C is 0. If C is 0, then it is RA. C is 0, it is R into A, minus C is 0, that is C is 0, then it is going to be S into B. Again C is 0, so this is 0 and this is equal to 0. Then we get RA is equal to S into B. This is being equation number 2, right? Now if we divide equation number 1 and equation number 2, what we get? P by R, if you divide P by R is equal to Q by S. If we divide 1 by 2, if we divide equation number 1 divided by equation number 2, so we get P by R is equal to Q by S. Clear? You can take the screenshot. You can take the screenshot. And you get P by Q, R is equal to Q by S, and transposing you get P by Q is equal to R by S. This is called balanced configuration. This is called balanced configuration of 4 resistances. So what we learned here, if no current passes through C or this arm, if no current passes through this arm, if there is no current, then P by Q is equal to R by S. P by Q is equal to R by S. Clear? So using Kirchhoff's law, with the help of Kirchhoff's law, loop law, there are two loops, and we solve the 2 loops according to that Kirchhoff's loop law. And after solving the 2 loop and making C, that is the current which is passing through X, making the current through C is equal to 0, what we get? P by Q, our desired result, we got P by Q is equal to R by S. And we will use this thing, so many numericals. Clear? So we will also solve some numericals on this result. And also we will there is another instrument which is very much useful in your course, that is meter bridge. And next video I will let you know how a meter bridge work on this Wheatstone bridge principle. Okay, so happy learning.